Hi Alex, I am thinking about majoring in physics, and was wondering if you could tell me about what you have learned in your astronomy class.
Sure thing, Brandy. What would like to talk about? I know you have already taken Physics 1021, the solar systems of astronomy. Have you taken Physics 1031, stars, galaxies and the universe yet?
Yeah, I have taken both of those courses. I really liked them, and that is why I am thinking about becoming an astronomer one day. I know you have taken astrophysics. How was that? What kind of things did you guys cover in class?
Yeah, Brandy, I did take that class last year. It was way more complex than the 2 intro classes you have already taken. So do you want to go talk about it over dinner?
Yes, that sounds great.
So where would you like me to start?
What topics did your teacher cover during the semester?
The first topic we covered was celestial spheres. It talked about Plato's theory of a geocentric universe. This means the planet Earth is the center of the universe and everything revolves around it, even the sun.
Plato must have got this theory from how the night sky revolves about a fixed Earth. It sure gives a feeling that Earth is not moving.
Yeah, exactly. We also learned about how planets have retrograde motion. This means our planet reverses for a period of time before it resumes back to its previous path. Also, Copernicus suggested a heliocentric model of planetary motion. This means the sun is the center of the universe. 1 second while I get my iPad out to show you a few slides of some more topics we covered in the celestial sphere chapter. This slide is a photo that demonstrates the equatorial coordinates versus horizontal coordinates. It also shows the ecliptic planes the sun travels throughout the year. Brandy, you may recognize this slide. It shows the right ascension, which is usually measured in hours, minutes and seconds, where 1 hour is equal to 15 degrees. This slide also shows the vernal equinox and the celestial equator. This slide has a few important points about celestial coordinate system. So that basically covers chapter 1.
Thanks, Alex. We will have to get together another time so I can hear more about this class.
I hope me summarizing celestial spheres helped you get a bit of an understanding about astrophysics.
Maybe you could quickly tell me the other topics you covered.
Sure thing. We covered celestial mechanics, which talked about Kepler's 3 laws. We talked about ellipses and other conic sections. Celestial mechanics also covered gravitational potential energy, orbital velocity, perihelion and aphelion velocity and escape velocity, which helped us to understand the equations regarding gravitational and orbital motion.
Did you do any major projects?
Yes, I did a project on the history of the virial theorem.
Can you tell me more about the virial theorem?
Of course, Brandy. Why don't you sit down and watch this clip with me?
Hi Rob, did you know in 1870, Rudolf Clausius delivered the lecture on a mechanical theorem applicable to heat, to the Association for Natural and Medical Sciences of the Lower Rhine. It was a 20-year study of thermodynamics.
Yes, I am aware of that. The lecture stated that the main V of the system is equal to its virial.
Yep, a better way of saying it is that the average kinetic energy is equal to 1/2 the average potential energy. Known as the virial theorem, it can be obtained directly from Lagrange's identity, as applied in classical gravitational dynamics.
The theorem was later utilized, generalized and further developed by people such as James Clerk Maxwell, Lord Rayleigh, Henry Poincare.
And do not forget, Subramanian, Chandrasekhar, Enrico Fermi, Paul Ledoux, and Eugene Parker.
Yes, sir. And of course, Fritz Zwicky was the first to use the virial theorem to deduce the existence of unseen matter, which is now called dark matter.
There are many ways to apply the virial theorem, but one example is, it has been used to derive the Chandrasekhar limit for the stability of white dwarf stars.
I bet with your genius mind, you can do the time derivative of the virial theorem in your head.
That is right, Rob. However, I must do this silly dance to keep my concentration, to do such long derivations.
Did you know the virial theorem can be extended to include electric and magnetic fields?
Well, of course. Rob, how do you think I made that MRI machine to scan your brain?
Oh, of course. I forgot. But in 1911, Henry Poincare applied a form of the virial theorem to determine the problem of cosmological stability.
But it was Lord Rayleigh, in 1903, who published a generalization of the virial theorem, as we know it today.
Wow, Alex. That was great. I did not know one theorem could be used in so many different ways.
Yes, Brandy, I am glad you learned something. However, I need to go. I am meeting some friends to work on an E and M assignment.
Okay, Alex. Can we get together tomorrow? And maybe you could tell me about some more topics you covered in astrophysics.
Sure thing, Brandy. How about tomorrow we meet for lunch and talk about Lagrangian points and all the different types of telescopes?
That sounds great, Alex. See you tomorrow.